think something that is underappreciated or maybe misunderstood about innovation, or a lot of people misunderstand about innovation, is there's an old view about innovation that it comes out of the ivory tower from the university, perhaps, the research labs, and then it comes down and makes its way into the world. And there are examples of where that happens. So the development of nuclear energy and the nuclear bomb came out of that type of effort. Pharmaceuticals come out of that kind of effort. So a lot of the life science innovations that we come up with come out of universities, and there's a whole ecosystem for doing that. But so much of what innovation is today doesn't follow that pattern at all. So if you think about the Wright brothers developing the plane, or semiconductors is a great example, where you have products that are out there in the world. Someone sees an innovation. They say, well, what if we do this? And a lot of it is very incremental. And then they go back and forth between the research lab and the manufacturing, back and forth, back and forth. And it's a very iterative process. And in fact, this is really where most innovation happens. It's driven by someone in the commercial sector, in the industrial sector, and it may be going all the way to a university research facility, but very often the industrial research facility, and innovating that way. I mean, the two things that come up a lot is money for research, particularly university research, the kind of competitive research that companies just aren't really doing enough of. So once upon a time, there was more government there's more spending from governments on this kind of research, and also you had companies like Bell Labs, AT&T Bell Labs, and so forth, that would invest a lot. Now it's changed a bit, where there's a lot of innovation by acquisition. You say, well, Google and some of these companies, they'll go out and look to see what's out there and maybe acquire it, but somebody still has to do some of the fundamental research. The other thing is the workforce. Huge issue, and it's hard to say which one comes first. This is so important that and it doesn't matter whether it's US, Europe, China, Taiwan, they're complaining that they either today or in the future, both, that there's not enough workers. And you hear about it applied to quantum, but it's everything. And it's not just PhDs, it's down to technicians, and it's the whole ecosystem of workers companies are complaining about. And that's not an easy problem to solve. It's going to take years to keep working on that. One of the problems with the skill shortage, I think it's easy to take it for granted because it's the kind of thing where it doesn't necessarily show up in a very explicit, tangible way. So if a company can't grow more than it does, or can't grow because it doesn't have the workforce, well, that's an opportunity cost, but anybody outside the company might not necessarily know about it, right? And so you have that sort of situation that's going on. Or here's another one. When people talk about supply chain issues, in our industry, it's not about the ships that are docked offshore in Los Angeles Harbor or in Europe. You'll see that in the paper. You'll hear that a lot. And that might impact whether you can get a washing machine or a car, something like that. But it's not really impacting our industry. Our industry is using planes and all that sort of stuff. They can get stuff places if they really need to, even across oceans. But why is there a chip shortage? Is there a shortage of certain materials that you might need? We've heard about packing materials. Well, it could be the materials themselves are hard to get, but it could be that somewhere in the supply chain there's a worker shortage or a shutdown or whatever, where the materials are not getting out of the factory because of a worker shortage. You won't necessarily know that. All you know is you don't have the packing material, or you don't have the wafers or the chemicals that you need to make your parts. More money. That's definitely a big factor. We can't solve everything, but it is, if you go to policymakers and you say how great the photonics industry, they'll say, well, okay, then you don't need any money. But to remain strong and to be competitive and continue to innovate, it does take investment in fundamental research. Again, that pre-competitive research. The industry can do very well when the fundamental work is there, but it's very expensive or even impossible for them to do a lot of the fundamental work. And then the other thing is the workforce. So what universities do is they do that fundamental research and they graduate students. And again, the students are all the way from high school and technician level up to PhDs, but that takes investment. And again, if you're going to train people in certain areas, well, then you have to fund projects for them to work on. If they're going to be working at the graduate level or PhD level, then they have to have projects to work on. And that takes funding. So I think that is definitely an area that can, whether it's Europe, the US, Asian countries, it's kind of the same problem all across the board.
Mm.
They're facing a challenge that they're getting priced out of the labor force. So if you're an SME, a small company, and then you're competing against the large companies, they could be the big data center companies or Apple or the car companies, they're coming along and they can pay higher salaries to workers that you need that are very skilled. And so when there's a worker shortage, it becomes a bidding war, you could say, to put it very simply. Maybe in reality, it's more complicated than that, but that's kind of what it comes down to. And so a lot of the companies that are going to get shortchanged are the ones that are on really limited budget. They're, maybe early stage and so forth. And so I think that's very hard. How to solve that is a big challenge. Again, you can't just turn a knob and graduate a lot more students. There can be workforce policies done by governments, but it's not an easy problem to solve. I guess one way that you can turn this around is you could say, well, these are good problems to have. The opposite is a bad problem, where you have too many people and there's a recession and people can't find jobs. And we are far from that, very, very far from that. So if there's any sort of silver lining in it, this is a good place to be. It's very difficult for small companies. I really have sympathy for them. The younger people coming out of college or entering college today, they have a lot of choices. If they go into STEM subjects at all, it may be computer science. Life sciences is a very popular one. Computer science is huge. And hardware, in particular photonics, it doesn't have brand recognition. It's not a household word like some of these other areas are. So that is a bit of a challenge. And again, this is being faced in places that you would never expect it. So it's a challenge all around. One place that is mentioned, I hear it a lot in the US, and sometimes this has really good brand recognition, is the Fraunhofer Institutes out of Germany, where they're sort of connected with the university research, but also industry, and they're kind of a unique setup in that sense. In the US, things operate a little bit differently. There are actually a couple of institutes in the United States, a few of them. And in the US, the way that they run national labs is a little bit different. So I'm not sure that, every case is a little different. It'd be hard to sort of really go through and compare here. But that is one that has branded recognition outside of Germany as a place where there's this convergence of the academic and industrial environment, apparently in a very successful way.